Hi guys, hopefully everyone can hear me. Um, Welcome to the final session of our training program on GIS. We'll start in a couple of minutes, just waiting for other people to join this meeting. In the meantime, I am sharing this link. Just go ahead and open it. I'm sharing it in the chat space. Just click on that and just open it on your browser. I think a lot of people have joined the meeting, so I think we can go ahead with it now. For people who joined later, I think I've shared um, I've shared the link with you. Yeah, you can mail us. Susan will reach out to you. Don't worry. I think she's got your mail, so she will reply back. Just for so we haven't started yet. For others who joined just now, we haven't started yet. But I'll just share the link with you once more. So just open this on your browser, and I'll walk you through what this is about. But just for the time being, I've shared it in the chat space. So just click on that link. So if you've clicked on the clicked on the link that I've shared in the chat space, this is the page that's going to open. It's called interactiveatlas.ipcc. So what you're seeing here is this is a data set by IPCC. This is IPCC's Intergovernmental Panel on Climate Change. So they did a modeling. They did some modeling. This I think this data came out in 2021, and I'll walk you through what this data is about and why we are doing it. But what I would like you to do is just click on simple climate feature, not advanced. Just click on simple. We are focusing on simple for the time being. Let's click on that simple here, and you can close this. Okay, so you see here what it's written. It's CMIP 6, mean temperature changed in degrees, warming 2 degree, SSP 5, 8.5 relative to 1850, 1900. Anyone has any idea what this is about? Anyone wants to give it a shot? Like whatever your understanding is, it's absolutely fine. But I just want someone from the participants to, if anyone wants to give it a shot. Anyone has any idea like what we are looking into?
I think the warming,
Yeah, please go on, ma'am.
yeah, I think it's a warming of the countries when the temperature is 2 degrees Celsius more than the, so it's each region's
Yeah, yeah,
colors are showing each region's intensity.
yeah,
If there is a 2 degree centigrade warming of the earth.
yeah. I'll just add a little bit more to this. What Pramila said is absolutely fine. What you're seeing is the world warming at 2 degrees, and some more context to it. So it's basically when the world's mean temperature would be 2 degrees above the 1850 to 1900 average, and that is a very important factor. Okay, so that will show like how warm the world is. You always compare like when we are talking about the world is getting warmer, the world is getting warmer, what we mean is the world is getting warmer compared to the 1850 to 1900 average, which is a 50-year average. So say if your 50-year average is 1.5 degree, and now the world is warming 2 degrees more, so the world is warming at say 3.5 degrees. If the 1850 to 1900 average was 1.5 degree, the world's mean temperature was 1.5 degree. Now, like in 2026, the world is warming at 3.5 degrees. And when the world is warming at that, like 2 degrees above the 1850 1900 average, what's your region warming at? The one aspect of this data is we know that the world is warming at 2 degrees above the 50-year average. But another aspect of it is, so now that the world is warming at whatever the rise in temperature is, what is your region warming at? So that's the data that we are looking into. Any questions regarding the data set? Any questions? Was I able to explain it? Please let me know. I'll explain it once more because this is a very important, part of it. Because end of the day, you have to understand what the data is, not just work on the data, but first you have to understand what the data you're working on.
Ulaha, please explain again. Thank you.
Yeah, hi. Yeah, so ma'am, if you've joined later, we are in this, you can see the world, and there's a lot of colors of red.
No, I got that. Just the last bit then.
Yeah.
Thank you.
I'll just say, I'll just explain from the beginning. So right now it says CMIP 6 mean temperature, whatever, warming at 2 degrees at SSP 5, 8.5. Okay. Now I'll break down all of them. So the CMIP 6, it's a kind of modeling. It's a kind of model that a lot of scientists use. The variable we are looking at is the mean temperature of the world. It's the mean temperature. It's the mean temperature change. Sorry, not mean temperature, mean temperature change. Okay, so mean temperature change is a very important factor, and I'll come back to that why. So that mean temperature change is basically the 2 degree mean temperature change from the 1850 to 1900 average, and that is very important. That 50-year average, whatever that was pre-industrial era. So whatever that average was for that 50 years, which we don't know, but it's not very important. What's important is compared to that average, now the world is warming at 2 degrees above that 50-year average. So now that the world is warming at that that 50 years average, 2 degrees above that 50 years average, what would your regions be warming at? So what you're seeing right now is, say, like, so when the world, so this model is based on if and when the world's mean temperature would be 2 degrees above the 50-year average. This is how other parts of the world are going to warm. This is the scenario. Basically, this is a scenario based data. Okay, it's not an observation based data. It's a scenario based data. So it might happen or it might not happen, we don't know, but it's what it is. And so was I able to explain it, Anandita?
Yes, Pulaha, thank you. I got that.
Yeah. And now this data, if you see, it's a little different to the data that we've been working on. And this is a raster data. This is what I mean by a raster data. So what is the raster data now? Now, if I zoom in, you see there are little grids of boxes, and that's the thing with raster data. Unlike vector data, which no matter how much you zoom, it's never going to pixelate. But the moment you start zooming in a raster data, it starts pixelating. It's like you'll see those boxes of color because the data is stored as pixels. Okay, and that's a very important distinguishing factor between a vector data and a raster data. So that's what a raster data is in a nutshell. And to do that, what I want you to do is, now you have seen a lot of other, like his variable is a quantity and scenario and season, and I'll go through each of them. So the variable we are looking at is the mean temperature. Okay, that's the variable. There are other variables as well, but we are focusing on mean temperature. Quantity and scenario, we are looking at change. We are not looking at values. we are looking at change. Okay. You can look in a free time, you can also look into like how the value is different from change. But for the time being, we are focused on warming 2-degree change. Okay. And the season is annual. So these are the three filters that we have to use when you are downloading this. Keep that in mind. Don't change anything here, because otherwise the results will be different. It's only going to end up confusing the participants. So I would suggest that you keep these as the same. This is the mean temperature, 2 degrees, and for annual. And what we are going to do now is we're going to go here, download here. And when you click on that, you have three options. Now, the PNG one is, we are familiar with PNG. What's a PNG file? I'm guessing everyone's used a PNG file. Now, there's NC, that's called a NetCDF, and that's GeoTIFF. So raster data, again, like we saw with shapefiles, shapefile is one vector data format. So raster data also comes in different formats. One is a NetCDF, the other one is a GeoTIFF. Now, the difference between GeoTIFF and NetCDF is the way they store the data. I'm not getting the depths of the actual differentiation. What I mean, the differentiation between what's a NetCDF data and what's a GeoTIFF data. But for the timing, we'll focus on GeoTIFF. You can go ahead and just download this GeoTIFF data. Just in case you're interested, you might as well also download NetCDF just to see. In fact, like after the class, you can just check yourself. The data is going to be the same. It's just the way they store it. So there's not going to be any difference in terms of output or anything. But I'll just focus on the GeoTIFF data, and these are the two most common formats of raster data. So I'll click on download as GeoTIFF.
Can I just ask one small question?
Yeah, please go ahead.
What is the difference between the vector and the raster?
Yeah, so if you see, I'll just tell you about I'll quickly tell you about the raster. Now I'm zooming in, right? So if you see, the moment I start zooming in, let me just bring it here. The moment I start zooming in, it starts pixelating, right? The data starts pixelating. You see, there are boxes, Now, if you do the same with any vector data, it's never going to pixelate. You can keep zooming, and it's never going to pixelate. So that's the biggest difference between raster data and a vector data. Okay.
And in like last time we did vector, we had
Yeah, last time we did
clear
vector.
geographies defined in that. And I think here we are just having an outline of the world map. Is there some differences like that also? Or just
So let me just import it and you will see. Let me just import the data and you will see. Okay. So let me just open QGIS now and close this. And I have open, and the way you import a raster data is pretty much the same. This is the browser, and I think I saved it here as downloads. Yeah, CM IP6. So let me just yeah. So let me refresh it, and this is how you can refresh. So if you have got a new file and if it doesn't show up in your browser panel, just hit here, just click this refresh, and yeah, now it will show the updated list. And so there might be two files, consensus.tif and map.tif. I think it's the map.tif. So let me just, and the way you do it is again like the way you do with shapefile, just drag it here and this thing opens. Okay. Another way, of the official way of importing raster data is, I'll just remove this, and if you come here, this is add raster layer. And by the way, you can do the same with vector. Okay, with the when you're importing a shape file as well, and I'll show you how to do it the official way. I think I just showed you the drag and drop process. I'll just show you the official way of importing vector layer as well. But for the timing, let me just import the raster. So you come here, add raster layer, click on that, and here you click on these three dots, browse. I'll go to downloads again and CMIP6. CMIP6, yeah. Map.diff. Open. add. And that's how, and that's the official way of here. And now we need some boundaries. We need some boundaries. I'm not doing anything else right now. It's going to look like black and white, and that's fine. You won't be able to understand what we are looking at, but that's fine. We'll do some styling later. But first, we need some boundaries, and for that, what I'll do is, I'll this time we'll look into another vector data format, which is a GeoJSON file. I just want you guys to be used to the different types of data formats, spatial data formats, and I'll just share this link with you where you can download the continent boundaries. I'll share it in the chat space. I have some questions here, Pranav. As when we say season annual, does it mean the rate of annual change is 2 degree? It's not the rate of annual change, Pranav. It's rather like the world has warmed 2 degrees more than at what rate it was warming at for the 1850 to 1900 average. So say if the 1850 to 1900 average is 1.5, and now the world is warming at 3.5, so it's a 2 degree change. So we are focused on the change rather than the rate of like that. So, and I've shared the link with you here in the chat space. Just click on that link and it'll open this page. And what we are going to do is, instead of a shape file, we are going to look into GeoJSON. And by the way, these are all vector data formats. Okay, these are all vectors. You can have GeoPackage, you can have Excel. I'm not very sure about it if QGIS recognizes that. I have to see it myself. I normally try to avoid Excel because it normally doesn't, QGIS doesn't recognize that. And there's shape file, there's CSV. CSV would be a delimited layer, so we don't need CSV. It's mostly CSV is mostly points layers, point type data. We have already got used to shapefile, so you know what's a shapefile. What we are interested in is GeoJSON, and GeoJSON is again another type of data format. And GeoJSON is mostly used for web applications, but QGIS also recognizes it. So we'll click on download. Before we go ahead, any questions regarding this? Anyone has any questions? Okay, so mine is downloading here. And I'll go back to QGIS and the official way of, and let me just see world continent GeoJSON. The official way of importing a GeoJSON file is, or a vector, any vector file, irrespective of what the format is you click on the first option here in the Manage Layers toolbar, Add Vector Layer. And by the way, you can do the same thing here. If you don't want to do from the Manage Layers toolbar, you can do it from here as well, Add Layer. I just find this one more convenient, so I make sure I have this Manage Layers toolbar. And you click on the first option, Add Vector Layer. You click on this button here. Sorry, this browse button here. And every time you see these three dots, that means that you have to click on that to if you're trying to get something, load something on QGIS. And I think this one was, let me see the file name, world continent. So yeah, the last one, world continents. And this is the you can open it in a text editor and see what the contents are. I'm not getting into that, but this is more or less the raw structure of a GeoJSON file. I'll click open and I'll add. And someone was asking me the difference between a raster and this is a good place to start. And I'm not changing any color or anything. I just want to show you the difference. Now, if you see, this is a world continent, as we say, is a vector layer. And by vector layer, I mean, say you keep zooming in, and it's not going to pixelate at all. No matter how much you zoom in, it's never going to pixelate. Okay. And now if I uncheck, and now if I zoom on the raster, see it starts pixelating. So that's the difference between a vector layer and a raster layer. Any questions here? Let me see. Will you please share the link? Okay, I have already shared that. Any questions before we go ahead? Any questions? Okay. So the first thing.
Just repeat how we can add the layer.
Oh, okay. Which layer? The raster layer?
Yeah.
Okay. So what you do, sir, is either you can drag and drop this. Okay. You come to browsers, you go to the folder where you have saved, and you just drag and drop like this. And the official way of getting it, like I find this very a little more convenient. All you have to do is just drag and drop, so that's why I use that. The official way of doing it is you come to add raster layer, you click on this, and then you navigate your way to where you have saved the file. Mine is in download CMIP6 folder, and this is the file we're looking at, map.diff. And then you just click on open. Okay, and then you just add as well. Okay.
Okay, but I'm not able to find that TIF file. Okay.
You have to navigate to where you have downloaded, sir. Like in my case, it's in the downloads folder in the browser panel. So you have to navigate to that folder.
Okay. Okay.
Okay. Yeah. I'll just style this properties. I don't want any fill color here, so I'll just drag the slider to 0% and then click apply. Okay. We have the outline and that's what we need. And now let's start working on the raster, which is like the map here, as it says. The first thing I'm going to do is I'm going to style it. I don't want this black and white because I don't understand anything. And I'm going to click on properties. And the way you style it, okay, let me just show you. And the way you style a raster file is, again, you click on that, right click on that, properties, again, come to symbology. Here's the render type. I'm not getting into all like what all they do. You can check it out in your free time. The one that we are concerned about is single band pseudo color. Okay, single band pseudo color. It says minimum 0.63 and maximum is 8.09. So the range at which they would be warming, the different parts of the region would be warming at, when the world would be warming at 2 degrees compared to the 50-year average, the pre-industrial era. So you have a range here which says 0.63 to 8.09. And I'm going to change the color. And here comes some core aspects of data visualization. And I'll tell you what these are. So if you see this color ramp, it has shade of from, I think, brown, dark brown to dark green. Now, this kind of color division variable, the distribution over the variables, we don't need it for this data set because this kind of color ramp is normally used when you have negative values. Okay, when you have, say, like from -5 degree to +5 degree, that's when you use a color ramp like this. Okay, and it's called a diverging color ramp. We don't need that. Our values 0.6 to 8, it's increasing gradually. So it's a sequential style. So we need a sequential color ramp. And for that, you come to color ramp here. Sorry. You click on this triangle. Click on this triangle and this thing opens up and you have a bunch of colors, but we want more. So you go to all color ramps. Okay. And here, so these are the diverging ones, red, blue, red, gray. Okay, and we don't need that. What we need is sequential. So I think yellow, orange, brown, yellow, orange, red, or just red. I think I'll go with just red because we're talking about warming. or I don't know, maybe even yellow, orange, red. Yeah, yellow, orange looks a little better if you ask me. And here's the distribution. You can see the lightest color is also what the 0.63 is. So that will denote the lightest color, and accordingly it will go up. So, and I'll hit apply. And now it looks a little better here. From the initial observation, can someone just give me what they're observing right now? Anyone wants to give it a try? So from your initial observation, what does it look? Anyone? Just give it a try. It's absolutely fine. We're just like trying things out here. So it's absolutely fine. Whatever your observation is. No one wants to give it a try. Something in chat. The Arctic is warming the fastest. Yes, the Arctic is warming the fastest. So if the Arctic is warming the fastest, we also have a projection now which will only show Arctic Circle, and that's where projections come in as well. What I'll do is you come to EPSG 4326, and if it doesn't show here, I had saved it as Arctic Circle. If this Arctic Circle thing doesn't show, you remember we had gone to user defined an Arctic Circle. So that's another way you can get this projection, because we had stored it in the user defined one. We had defined it, so it will be under user defined, unlike the preloaded projections that come with QGIS. So I'll hit apply and let's see. It'll take some time to, let's see what it shows, or if it shows up. Sometimes, yeah. See, this is how it's looking. There's a slight, I think, this color, which I'm not very happy with, but it's fine for the timing, it'll do. And this is how Arctic would look. If you just want to focus on Arctic Circle, you see these areas of Arctic Circle are going to warm the fastest. And I'll go back to my default projection, which is a 4326. Yeah, Arctic would be warming at the fastest. And I'll show you one more feature. And if you zoom in, you see all these boxes, and all these boxes store their data. And I want to, specifically check, if I want to check like any box for that matter, how much the warming is. In order to do that, you have this, I think this is called identify features, if I'm not wrong. I don't know why it's not showing up, but if you have this eye with a mouse, you click on that. Does everyone have it? Anyone who's missing this, but anyway, let me know in the comment section. I'll just click on that, and now you see this thing changes, and I'll just click on any box. See this box, and it shows 2.165719. So this is also like, just in case you want to get specifics of like what, like say like India. I think this is the Indo-Gangetic, Uttar Pradesh, if I'm not wrong. Any place in Uttar Pradesh, that will be 1.5. Let's go to Arctic Circle, anywhere in Arctic Circle. This is 5.91. This is 6. So like that, if you want to specifically check a region, check a place, or the box in this case, that's how you do it. Okay. And let us go back. And this is great to see and everything, but we want to get into the specifics of it now. And by specifics, I mean, like, I want to know which continent would be warming the most. Okay, when the world would be warming at 2 degrees above the 50-year average, what would be the other continents? What the other continents would be warming at? Say, like, what would North America be warming at? What would South America would be warming? What would Africa, Asia, like that? So, and QGIS stands for Quantum GIS, and that's the biggest, that's the most powerful thing about QGIS, is you can actually get into the specifics of it. You can actually quantify things here, and that's what we are going to do. We are again going to quantify this spatial data set, and I want to see like which continent would be warming at, or at the change basically. So in order to do that, so you have processing here. Click on processing toolbox, and let's look for zonal statistics. Zonal statistics. In mind, this is the last option, zonal statistics. You click on zonal statistics. You click on the input layer, which is going to be your vector layer, and your raster layer, as it says, as the name says, it's map. Now, here are a couple of statistics to calculate. What we are looking at is mean. We don't want count. We don't want sum, median, or standard deviation or anything. We are looking at mean. You can try a bunch of other things like, all these things in your free time. Feel free to do that. We are focused on mean, because end of the day we want to see like what's the mean temperature of that continent is going to be like the change in mean temperature, basically, to be more specific. And we're going to hit run here. And before I get into that, and it creates a file called zonal statistics, and that's great. Before we get into that, remember like last time when we were trying to quantify that vector data, like on fire activities, we had this issue of fixing that shapefile. But in this case, we did not have to fix the shapefile. It just generated the data that we wanted. Makes our life easier, great. But we did not have to, and one reason is because probably this file was never edited. None of the lines or anything for that matter was edited, so this file was good to go from the going. So that's why we didn't have to fix the shape file. In most of the cases, if you're working with countries or states or anything like that, most of the times you might have to fix the shape file. In our case, we did not have to. That's a good thing. But I just wanted to say that, like, mention that point. And what we are going to do is right click. We're going to see now the results of it. And the way you do it is, again, zonal statistics, right click on that, and you hit open attribute table. That's where the data is stored. And now if you see Africa, you see this mean, they've done a column here, and it says 2.40. Okay. Asia, and every time you click there, it's also going to denote, okay, this is where you stand. Mean 3.15. Okay, so Asia would be warming at 3.15. Australia, it'll be 2.17. Oceania, 1.64. South America, 2.25. Antarctica, 2.27. Europe would be 3.24. Okay. And North America, so North America would be warming the most, by the way. So if anyone's there from America, let your prime minister know, your president know. That's how it's going to roll. When the world would be warming at 2 degrees, North America would be warming the fastest, more than Europe and more than Antarctica. Now you might be thinking like, why we don't have Greenland? Because we are focused on focused on continents. So that's why I think Greenland comes in Europe, if I'm not wrong. So that's why, just in case anyone's figuring why we don't have Greenland. So anyway, and now if you want to do away with this yellow thing, what you do here is, you see this, come here, this yellow, two layers, and then a stop sign. You click on this, deselect features from all layers, and it's going to deselect. And what I'll style this a little bit, properties. Apply. Okay. And before we go ahead, any questions? Was everyone able to follow what we did? Any questions? I think I see a question here. Could you repeat the last, which part? Which part? The zonal statistics. Okay, I'll just show you the zonal statistics once more. I'll just delete this zonal statistics. Just delete this layer and I'll just show you the whole step once more. Okay, so now we have the two layers again, and what we are trying to do is we are trying to quantify the map layer. We want to see like which continent would be warming at what rate when the world hits the 2 degree mark, 2 degrees change from the 1850 to 1900 average. In order to do that, in order to quantify that data, the raster data, you'll go to processing toolbox, and you're going to look for zonal statistics. We are under processing. This is the way to go. Processing toolbox, and then you look for zonal statistics. Zonal statistics. Your input layer is going to be your vector layer. This is a GeoJSON file we downloaded. Your raster layer is the map. This is what we're trying to quantify. And the statistics to calculate here would be mean. We are interested in mean change basically. And you click on run, and that generates a file, zonal statistics, open attribute table to see what the figures are, and North America is 3.45, like that. Any more questions? Were they able to explain to you how you can quantify spatial data, how you can quantify raster data, to be more specific? Great. I think we can go ahead now and actually export the map that we have just done quantifying. So let me just uncheck because we don't need the zonal statistics here. And anyone remembers how we exported the map as a PNG? Anyone wants to have a go? Do they remember what we did in the last class? Anyone? Okay, I'll just go ahead, and if you guys don't remember, so this is the new print layout. The new print layout, you click on that. I'm gonna say 2 degree, 2 degree change. Name it like that. Hit OK. And one thing I'm going to do here now is I'll just change the projection to something that I like, which is sphere Molvid. Apply.
Was it like the drag of it was the dragging?
Sorry, which dragging?
Like you have to copy the map, you have to drag it. Is that what you're saying when you were copying? How do you save it as a PNG, you were saying?
Yeah, so you want to have a go, if you want to explain it to the class, if you remember.
I just remember in bits and pieces. I remember dragging.
That's fine. That's absolutely fine. A lot of clicks and everything. And
Yeah, because I did not really try. I just remember from the last class. I think you drag it from the left side, left topmost. You drag it to the right, right? The whole.
Okay, so that no, I was just it's part of it, but that part comes later. I'm saying like, how do you get into that whole, you start the process. How do you start the process of exporting?
Let me just try to recollect a little bit.
Fine, that's fine. But thank you so much. Thank you so much. I'll just close this box and I'll show you once more. And the way you do that is you come here. It's called new print layout. Okay. And in case if this is missing in your menu bar, menu panel, what you do is you can come here as well, project and new print layout. That's how you start the process of exporting a map. And How do we know that the mean quantifies temperature in degrees Celsius and not degrees? Very good question. And if you come here in the data itself, it says 2 degrees C. So it's already done. We don't have to convert or do anything like that. Okay. So we'll go ahead now and export the map. And here, this new print layout, and you can find it here as well. You click on new print layout. Change, I'm going to name that. And the new print layout opens this dialog box. And yes, you were right, ma'am. The way we start is now you come here, add map. And you drag from here to here. And see, and good that it's showing up like this. And I'm not very happy because there's a lot of white space here. There's a lot of white space, and the world is looking very small. Okay. And the way you fix that is, this is where you fix the extent. Okay, so your x min would be something like this, and x min would be, you come here and it's minus 188,35752, minus 188,35752. So you come here and see this thing increases. It comes to the left hand side. I think I'll go 188. Yeah, for the X max also, I think I'll keep the same. Click on this, and I'll fix this thing. It's going out of the artboard. This black thing is where your artboard starts and ends, and it's going out of it. But I'll fix this. Let me just fix the extents first. Figure out what the extent we want. Okay. And this one is 9556272, 9556272, and that would be your X max. Let's see. Yeah. And the X min would also be the same. Sorry, Y min would also be the same. Yeah. So now we have it, and we want to bring it down. So I'll keep it in the middle, or you can also bring it a little wherever you're fine with placing it. I'm good with this. Now we have the map ready. Was everyone able to follow what we did? Anyone has any question regarding what we did now? Okay, I'm guessing everyone understood what we did. So I'll just go ahead. And the next part is the legend. And for the legend, I think it's this one. Yeah, add legend. And I'm going to make a box here. And I don't want this. I'll change, because there are a lot of unwanted things that I don't want. So the first thing I'm going to do is uncheck auto update, and the zonal statistics and world continents. So I'm just going to delete these two. And let's see, let's bring it down. And let's just fix the size of this legend, because right now it's too small, and we'll figure out the other parts later. I think it's under position and size. Okay, let's see. Okay, this doesn't help. Let's just experiment a little bit, like which one should make it work. So rendering, no. Okay, this is no, not this one also. Just give me a minute. Let me just figure this part out. And this is where you normally, do some customization. Right now, what we are trying to do is we're trying to increase this legend size. And if someone, I mean, if your guys are working on this and if someone is able to crack it, can also share with us. But let me just, I'm also trying to figure out where, I think it's symbol. No, nothing happens here. Okay, so this one is changing the width. And I think this is the max symbol height. No, minimum symbol height. No. Hopefully this should work, but symbol width is working. Has anyone been able to figure out how we can change the let's see. No. Background. Well, it shows like the way we want it here. I don't know why it's not reflecting on. But if anyone is able to find this, please do share it with me. I'll look it in my free time, like how. Okay, the legend height. I think this. Okay, this is the WMS legend. I thought that's one. No, no, not using it. No. Anyway, I'll share it with you guys like after the class. We'll just go ahead and do the other things. What we'll do is I'll just clean this up a little bit. So legend items. The first thing is I'm going to change it to. Did someone share it? Let's see. Did get the value? Remove the band one right up. It will be solved. Band one right up. Okay. This one. Okay. Oh, great. Thanks a lot. Yeah. I think. And now should we just change the height? No. What we're trying to do here is we want to try something like this. And right now, this is very small. So Leela, if you can just share the process with us, with the class. I think I make it shorter. Okay, so you made it shorter. Okay, no. What we're trying is like trying to increase the height of this legend. Remove the word map. Okay. No, so that the whole thing goes away. But anyway, I'll just look at it myself. I'll just look it up myself. We have done it earlier, so
I think just simple dragging the box can solve the problem. And there is a text written like legend or index. I think it will be solved then.
were you able to increase it, the size?
No, I'm not doing simultaneously.
Okay, okay.
I just know it how to prepare the layout. That's why I'm saying this.
Okay,
You just remove the band one first, and then the box will be automatically smaller, and if you, there is a, yes, the symbol height increases 0, that portion. Yes, the size you can.
Not for some reason.
Uh,
Very weird. Now let's see.
no, it's not working. Okay. No.
Anyway, I'll just see it myself. Don't worry. We'll just figure that part out, like how we can increase.
It will take a
I'll share I'll share the video with you guys, with the class, the whole class, once this session is over. And what we're doing is, what we're going to write is something that people understand what this map is about, and which is warming change, 2-degree warming change compared to 2-degree warming change compared to 1850 to 1900. Average. I'll make it and I'll keep it here for the time being, and I'll just decrease the space between this form and spacing. Yeah, this is better. And I'll just change the font a little bit. I'll do the same for the I'll change it here. Courier. Let's increase the font size. 15, yeah. Actually, I'll just change the style to bold. People understand. I'll give a scale now. And initially it will say invalid scale, the scale bar could not be rendered, but that's because we have it in meters. When it comes to the whole world, it normally changes to map units. And do that, we'll again fix it a little bit here. And I am happy with the size. You can also change the size, I think, here or here. Yeah, the height changes. And I'll give it a headline, add label. I'm going to say world. See. To see the data, 3.4 degrees. 20. And I'll change the font style here as well. Font, go with Georgia. And I'll hit bold. I'll change the alignment a little bit. I think I'll keep it center, vertical center. Yeah. And one final thing is I'll give it a legend. I'll give it the source. For that, again, I'll make a text box here. I'll write this is IPCC. Yes. You should also give for ArcGIS. We downloaded the GeoJSON file from ArcGIS. And I'll just change the font here as well. I'll go to Courier. Yeah. And one last, before I go ahead and actually export the map, which is the final step, any questions regarding what we did and why we did whatever we did? Any questions?
Yeah, hi, I have a question.
Yeah.
So to begin with, like where we started from the IPCC, we got the warming data, right?
Yeah.
Yeah, that was a raster file.
Yeah.
And then we download a JSON file from another site.
Yeah.
And on that, I basically overlay this data, the raster data on that one.
Yeah. Yeah. Yeah.
Why we did not download shape file and why we downloaded.
Yeah, so I wanted the participants to get used to other data formats as well, you know. So
Okay.
we could have downloaded shapefile as well. It really doesn't matter whether you're using a shapefile or a GeoJSON file. The data is the same. But so the next time, say instead of shapefile, you see a GeoJSON file. So don't get confused. Like, okay, so what is this file now? We haven't used this. I'm not used to it. So that's why I want the participants to get as used to other data formats as possible. So the next time when you're doing GIS, when you're using QGIS, if you're not able to figure out, what's a GeoJSON file, now you know what's a GeoJSON file because you have used it. So like that.
Right,
Same
thank you.
goes for like I could have used NetCDF or GeoTIFF. In fact, I would encourage participants to just check like how it is the NetCDF file as well. The data remains the same, everything remains the same, but participants should get used to the different types of spatial formats. Whether it be vector, whether it be raster, just keep using different types of. Just expose yourself to different types of data formats.
Right, thank you.
That was the reason. Yeah.
So let me intervene at this stage. So again, an experience, Pulaha, if you remember. So in fact, IPCC had come up with an interactive atlas.
Yeah.
Okay.
Yeah.
And that had these maps were given you were there regional region wise. So
there was a world
content
map.
Yeah, it had different continents as well.
Yeah.
Okay. And then we had asked you to give us data for the cities. How are cities warming? Indian cities are warming. Okay. And then you had used this technology. We used QGIS to give us a story that
So we did not do it for we did not do it for cities, ma'am, because it's not that okay. So thankfully, because you brought it up, and it's a very important factor. So ma'am just said like cities, and we can't do cities. We did states, okay, and we couldn't do districts or cities. Why? I'll tell you why. Because if you come here, and I'll just show you properties. If you come to information, so the pixel size is 1 minus 1. Okay. And normally for cities or for districts, you have to go, the pixel size has to be way lesser than the one, I mean, what the pixel size says. I don't remember the exact unit of it, whether it's in centimeter, because this one, every pixel would also have a size measurement,
Yeah,
right?
yeah.
Whether it be centimeter or whatever the form, whatever the unit is.
Mhm.
So we couldn't do that, and we had to stick to states
Yes.
and countries and the world in general. So you have to be very careful with like what also you're trying to, you know, make sense of, because cities, because the data is not that granular for you to show cities or districts for that matter. But it's good enough for states.
Yeah.
It's good enough for country wise analysis, or or continent wise analysis that we just did.
I remember you also give us an analysis for African continent. It was
It was for African
yeah,
continent.
remember
We
that?
also did.
Yeah.
Yeah.
I have one more question, Pula.
Yeah.
So this is okay. Your story says when the world would be warming at 32 degrees Celsius, North America would be warming at the fastest, right? Followed by Europe. No. What about Antarctica and Arctic? Because
Yeah.
is it possible to show those?
So we do
aspects?
have.
So there's a surprise in that.
Uh,
Okay, there are polar regions.
Yeah, they are polar
Okay,
regions,
yeah.
but we don't. Just one.
And we've heard a lot about glaciers melting.
Yeah, and we won't have for Arctic Circle because it's not a continent by itself,
Okay.
but we do have for Antarctica, and
What
Antarctica
does that
would
show?
be. Yeah, just 1 minute. Antarctica would be 2.2. In fact, like it'll be like Europe and North America would be warming more than Antarctica.
Okay.
So yeah. Any more questions before we wrap it up? And
Yeah.
one last thing I'll share with you is like how we can fix this. And I'll just for the time I'll just hit like export, and the way you finally export this as a PNG is export as image here, and wherever you want, this is where you can look for whatever format you want. I'm happy with PNG. I'll save it in downloads. Save. And this is how your map looks. Except this part, I'm pretty happy with how everything else is looking. I'll send you a video of like what you have to do to just fix this part. But otherwise, it's looking pretty good. I'm pretty happy. Any questions before we get into the assignment, like what you have to do for the assignment?
I have one question.
Yeah.
This is what we have done for the world. So suppose I want to do some mapping for India. So the same procedure what we have followed will be.
Yeah, you'll follow the same procedure, ma'am.
Okay.
Yeah. And we have already done it for states. So I have a story based on this data itself, like how the states would be, the different Indian states would be warming at what rate. So
only the data set will be changed. That will be specific to the states of India.
yeah,
right?
the data set remains the same.
Yeah.
What we have to bring in is now an Indian shapefile, Indian state shapefile.
Yeah. Okay.
Yeah.
Thank you.
Yeah.
So where from state are you from? Which state are you from?
I'm from Delhi only.
Okay.
Okay.
Yeah.
Okay. Pretty says some websites to download it. It's for Indian cities. So there's no one website like where you can find for Indian cities. And for Indian cities, what you're looking at is municipal boundaries, right? There will be municipal boundaries. I think data meet. You can write it down. Data meet. So you can find. I think they would be having municipal shape files.
No, Pula, it will be really good and helpful to most of the participants. If you can share few sources for data at India for India.
For India, that would be
Yes.
data meet.
Yeah.
I'll just write it here. Data meet. They have a repository. They
Yeah.
have a repository, and also just do like it's pretty easy. All you have to do is just go to Google and just search for India shapefile. That's all you have to do, and whatever comes up. Let me see. Like, let me just try out.
Still,
Yeah.
despite that, Google is there.
Despite
Okay,
that,
but
yeah.
Pula is also there. Pula can help us.
I have no
with this.
Google, but I'll
Okay.
help.
So it will
I'll
really
try to
all of
help
us. If
out
you can-
India shapefile
yeah.
download. It's a very basic search, and so this one is survey. So, and you see all these GitHub accounts. If you are used to GitHub, GitHub also has a lot of people just sharing, good people sharing stuff, and the way you do it is, so these are a bunch of files that you have code. Come here, just download zip, and it'll download. So I'll share this one as well. Can we get it from Bhuvan or India Survey? So India Survey would, like, I think India Survey would be like you have to probably pay to the government of India. Yeah, I know it's bad, but that's how it is. Village level data. Village level data. I have to see it myself.
That's
If I
what
can
I'm
find
saying. I think you
something.
should share a list of these sources with the participants. Okay, it's a humble request.
Yeah.
From all of us.
Okay.
On behalf of all the participants.
Okay, but I would
Yeah.
encourage participants to do their own.
That is fine, but
yeah.
still.
Yeah.
I think we should all raise. You can just raise your hands if you agree with
I know
this.
everyone's going to agree with this.
Yeah.
But
It's a
I don't want to
thumbs up,
replace
yeah.
Google here. I don't want to replace Google here. Now it's the age of AI.
Yeah.
So I'm interested in showing data for IMF debt as well as countries that have IMF agreements that are conditional to export or export. What characteristics CV files, CSV files do I have to I want to have this because I'm creating my own database. I'll take it up with you, Lola. Can you just share me? Can you share whatever you need on a mail? I'll take it up with you because this is a little out of our domain, so I have to take it up with you on a one-on-one basis. So just
So Lola, just send a mail to us.
Yeah, and
we'll respond back to you.
we'll respond back to you.
Yeah.
Pollution again, same pollution parameters. IMD. I think CCCB is where you can get the data. CPCB. Yeah, you can get the data from there. I think Anand, someone called Anand, was raising a hand. So
No, that was me raising my hand
Yeah,
because
yeah.
Kiran said that I should raise my hand immediately
Okay.
for the resources.
Yeah.
And
Okay.
that Pula is going to be kind enough to send all the resources.
Sure, he will be kind with all of us. So,
After the
yes.
budget, we have a budget. We
Yeah,
have
so just
the
give us a
budget
day.
thing.
We are busy with the budget.
We have
Sure.
Yeah.
Thank you so
In
much.
case I'm not responding to any mails, is because we are all very busy in the newsroom with the Indian budget. So let us just finish that part and then I'll give.
Pula, you can take all the time you want, please.
I'm with Anindita now.
Thank you.
Yeah. Any more questions?
Yeah, I have a very trivial question. I'm not able to save the map that we created just now. You guided us to create.
Okay, so you have all this, right, ma'am?
Yeah.
All of
Yeah.
this.
Right.
Now, all you have to do is just come here. If you have everything ready here, all you have to do is just come here, this one, then the one next to the printer, okay? And this is, I think, I don't know why it's not showing the exact name, but all you have to do is click on this now.
Okay.
Yeah, save layout as, and this dialog box will open and you can just save it.
Okay. Thanks. Thank you. Yeah.
No problem. I have a request to all the participants now. Just in case if anyone is able to figure out this part, because this thing is bothering me continuously. Me being a designer, the designer in me is sort of, not very happy with the size of this legend. Normally, we have done it earlier, but for some reason, maybe there was some change in the setting or something. That's why I'm not able to figure it out. We have done it earlier, but please, if someone is able to figure this part out, do let me know and I'll look it up myself and I'll share a video, a small walkthrough on how you can do that. And now for you will also get now for the assignment, and you'll get an official mail from us tomorrow where we'll list everything. But what I want you guys to do is, let me get back here. So now we did this, right? Now what you have to do is, all you have to do is now once you have generated, and we have done it for continents, I would want you guys to do it for the world countries, okay? For the world countries, and for the world countries, the shapefile you can find it in Natural Earth. You're by now, hopefully, you have got used to Natural Earth, how to download from Natural Earth and everything, and where you can find the world countries data shapefile. Now we have done it for the world continents, zonal statistics. All you have to do now is come to properties, category, I think graduated, the value would be mean, classify, I'll just hit classify, and this thing shows up. I think natural breaks would look better, or pretty breaks. And I think I'll go with natural breaks. And yeah, so, and this is a choropleth map, by the way. Okay, this is a choropleth map, and it's not going to show anything because you have it unchecked. What you have to do is, once you have this data quantified for the countries, I just want you to export just this part. Okay, I don't want the raw data. I don't want the raw data, and by raw data I mean this. I don't want you to export this. I don't want whatever we exported now. What I want you to do is, we exported the map, this one, yeah. Remember, this is the choropleth map that we did for fire activities. We quantified the fire activities and we turned it into a choropleth map. I want you to do the same. I want you to export the choropleth map of the raster data that we just quantified. And the raster data is this one. Okay. Now I want you to turn this into a choropleth map, the raw data into a choropleth map.
And the story should be around the countries.
Around the countries. It's very important. The story should be around the countries, not continents. We did the continent part. I would like you guys to do the, I would like you guys to do on world countries and projection of your choice. I would be happy if you can, apart from 4326, if you can do it with some other projection. Were we able to explain? You'll also get a mail, so don't worry. You don't have to write it down. You'll get an official mail from us listing what all we need. But any questions regarding the assignment itself? Any questions? Was I able to explain it? No questions. So I think we are good. I think I was able to explain to everyone. Yes.
There's one more announcement.
Ruchi
So
says
we have
yes.
got my request because there's a deadline to give the project and assignment work. Okay. But we do understand people have their own limitations. They're also working. So keeping that in mind, we will be extending the deadline to give the assignment by at least 8 to 9 days. Don't worry.
Yeah.
And we'll share a mail with you with a new deadline for the assignments. Okay. So you get at least 10 more additional days to finish this work. Are you all happy with this? I hope this will be, so it will make work much easier.
Also, a lot of people ask us, why are we not grading? That's not the end goal here. The end goal here is whatever you learn. It's not about like how much you scored. Like we don't grade it. Rather, we just see like if the participants were able to follow the steps and everything, and how much they did, like how much new things did they bring. I mean,
I think that's more important than the
grading. Yeah. Okay. What's more important is whether you did the quantification the way we showed.
Sure. So they'll do the assignment and they can mail this work to us, or they can also post it on the Moodle platform.
Just mail it to me and give a go ahead, and then you can just go ahead and post it on the Moodle.
Yes.
Just mail it to me first. I'll just have it. I'll have a go. I'll have a look at it. If everything is fine, I'll just give you a go ahead to post it on Moodle.
So we shall also send a mail to you on the assignment work that you're supposed to do. But if you have doubts, please feel free to write to us.
Yeah, please feel free to write to us. Thank you so much
for
attending.
Everyone. Thank you.
Hopefully you had a nice time.
One question was there.
Yeah.
These videos, these 3 videos, will they be available to us for?
Yeah. All the videos will be available.
After the coursework also?
Yeah, yeah, yeah.
At least for a month, they should be there.
We'll also be sharing all this. I'll be sharing a PPT with you that will go to all the participants, a PPT, a Google slide of the vector steps that we have. So you're good to go.
Okay, thank you.
Thank you. Do we have to pick a specific country for the analysis? No, I just want you to do for all the countries, all the world countries, and tell us like which country would be warming the most. Okay? Yeah.
India.
Suppose somebody wants to do something like this for their own country in that case.
Obviously, India.
Yeah, so India would be, I mean, you just bring the India shapefile and that's it, you're good to go. All you have to do is just import the India shapefile. You'll find it in Datamate or any GitHub repository. Just load that and just do the quantification. I've shown you the quantification process, like the steps involved. You can just do that and it's good. Okay. Anything else?
I think, yeah.
Okay, we'll wrap it up. Thanks a lot, guys, for coming.
1 second, please. So, have you already given any assignment? Because last day I was not.
No, don't worry, ma'am. Don't worry. Don't worry. You'll get a mail. Not yet.
Oh, no. You will mail us, no?
Yeah.
Okay. Okay, then. Okay.
Any other doubt?
Okay. Thank you.
Okay. Thank you so
Thank
much.
you, everyone.
Thank you.
So much.
Thank you so much.
Sure.
Okay.
Thank you.